everyone, welcome to Network Tutorials. In these videos, I will explain basics of networking and also OSI model and how the OSI model plays its important role in network traffic flow.
So let's start with what is network. On specific, what is computer network? So I would say a network is a group of two or more connected devices like computer, phones and servers so that they can communicate and they will share the data or services with each other. So when you connect your laptop to the Wi-Fi, it becomes a part of the network. So it can access the internet and it will share the files. So as a network engineer, we commonly use network devices like router, switch, firewall, server and client. When we talk about the router, so here I will give basic idea about all the devices. So going forward, we will discuss more about each device. So router, it connects the different networks. So like when we want to connect our home network to the internet, the router will plays a major role in the connection. So when switch will connect all the pieces within the same network. So it connects all the devices within the same network. Let's take an example of office. Like all the pieces in the office will connect to the same switch. And coming to the firewall, generally firewall is used to protect the network from the unauthorized access. So in the world there are many users in the internet. So some are authorized, some are unauthorized. We don't know how the users will act. So to protect our network from those unauthorized access, we use firewalls. For the individual laptops, we use firewalls in the software format. And for the large networks, we use firewalls in the hardware format. And the server is nothing but a device. It provides services, data or resources to the other computers called clients over a network. So when the client requests any data, like right now we are using YouTube. So when we request the your video to the server, so it will send that related video to our system. So our in this case our laptop or phone will be the client, and Google's computer that stores the website is the server. So now there are many servers like web server, file server and also mail server. And clients are nothing but, as I told before, the device which sends the request, it will act as a client. In this case, in the previous case, the phone or laptop is the client. In some other cases, the maybe server is also acts as a client. Let's talk about computer network types. So there are three types of computer network types we mainly used. So there is LAN, WAN and MAN. So coming to the LAN, it covers a small area like office or a home. So let's observe here, all the PCs and devices are connected to the same router. So it will comes under one LAN. And coming to the WAN, let's take, we have an office headquarters in the Boston and a branch office at the Chicago. To connect those two offices securely, we use WAN. So the WAN connect the LANs across the cities or across the countries as well. And then MAN. So let's talk about network standardization. So here we have multiple Dell PCs and a Mac OS PCs. So Dell has its own language, set of rules and protocols for the communication. So when they communicate within each other, they don't have any problem for the communication. But the Dell can't communicate with the Mac OS when we don't have any standardization, because Dell has its own language and Mac has its own language. When Dell sends the data with its own language, the Mac can't understand. So here we need a standardization between the different vendors. So it is the common problem over the internet. We need the communication between the different vendors from the different locations. To standardize this, OSI model is an attempt for the network standardization for the communication over the internet. So coming to the OSI model,
Generally, we are not using OSI model nowadays, but it creates a great impact on the networking. Let's discuss about it. So here OSI model is open system interconnection model. It is a conceptual, not any physical device. It is a framework that describes how data is transmitted over a network from one computer to another. So when one user sending the data from one computer, it describes how the communication starts from sender and it reaches the destination. So it divides the communication process into 7 layers. So each layer has its own role and a protocol. So it starts from physical layer, data link, network, transport, session, presentation and application layer. So mostly as a network engineers, we need to focus more on the transport layer, network layer, data link and physical layer. And the first 3 layers were used by the application developers. But I will give a basic idea about the application layer and presentation and session layer. Directly interacts with the end user or user applications. In simple terms, this is the layer where user actually see and use the network service like opening website or sending an email. So the protocols here we used HTTP and HTTPS for web browsing, FTP for file transfer, DNS for translating domain names into IP addresses, SMTP for sending emails. And also the main function the application layer involves in the identifying the communication partners, and also it synchronizes and establishes the communication between the other systems. And I want to discuss with an example like when you type www.google.com in your browser, so the application layer will send the web request through protocol HTTP. So the request will move on through the OSI layer to reach the server. Then the web page will respond and travel back up through the layer to the browser, and it will display it to you. So the application layer, the end user can directly interact with the browser. And then presentation layer. So presentation layer is responsible for the data translation, encryption and compression. And also it makes sure that the data sent from one system can understood by the another. Let's take an example of Dell and Mac OS. So Dell has its own language and Mac has its own language. When Dell sends the data in a particular format, so the presentation layer will make sure that data sent by Dell will understandable by the Mac OS. And also it converts the data into a format that receiver system can be understandable. And it ensures secure transmission of data between the browser and server. And also for the faster transformer, it reduces the size of the data. The main protocols here we used are SSL and TLS for encrypts data for secure communication, and JPEG and GIF for the data formats handles. This is about the presentation layer. And then coming to the session layer. Session layer, it is responsible for the establish, manage and terminate session between the two devices or application, like between local browser and web browser. So in simple terms, it keeps track of transmission between the two systems, so data doesn't get mixed up. So it sets up the system between the device, like log into a server, and it maintains the session during communication and close the session once the task is complete. So that's it about the session layer. And coming to the transport layer. So this layer is responsible for the end-to-end communication between the devices and to deliver of data between the devices. And also it ensures the data is sent reliably, completely and in the correct order. And also when it receives the data from the above layers, it will receive in the large data format. Then it breaks the large piece of data into small segments before sending, and it will reassemble them at the destination in correct order. So here the reason to break the large piece of data into small segments. So now we are watching the YouTube video. We have an internet connection problem. So when the video comes in the large piece of data, when we have a problem, the whole video will miss. We can't take that video come back. But when we make the large piece of data into small segments, even if you have a problem, the few packets may miss, but at the end of it we can receive the video, but only few packets will miss. So that's the main reason to break the large piece of data into small segments. Here we use TCP and UDP protocols. So if you want communication between two hosts be reliable and connection oriented, we use TCP. And if the speed is more important than reliability, like for voice or video traffic, we will use UDP. And moving to the network layer. So network layer is the third layer of the OSI model. It is responsible for moving data between different networks. Like this layer is responsible for providing connectivity and path selection between the hosts that are located on geographically on separated network. In simple terms, it provides the connection between the different networks, and it provides the logical address to the devices, so they can uniquely identify on a network. The source and destination IP addresses are added to each packet. So routers are operated at layer 3. So it determines the best path of data to reach its destination using routers. Example, choosing the fastest route for the packets across the internet. So when you send a message from your laptop from one place to another place, the network layer will assign an IP address to your device and the destination server. So and then it decides the best route through the routers and networks. Each router checks the packet's destination IP and forward it towards the target. Once it reaches the correct network, it passes it to the next layer of the delivery. The data link layer. So it is responsible for the node to node transfer, means it ensures the data is delivered correctly between the two directly connected devices on the same network. Example, PC to switch. And also it uses MAC addresses to identify devices on the same network, and it detects the errors that occurs in the physical layer, and also it and may request the retransmission. And the data link layer is adjacent to the physical layer, so it can defines how data is formatted for transmission based on the physical cable used, and how access to the physical media is controlled. And also typically includes error detection and correction to ensure the reliable data transfer. Here switches are operates at layer 2. And then coming to the physical layer, it is responsible for the actual physical connection between the devices. So it defines how hardware characteristics like cables, connectors, and voltage levels and signal types. And also it converts the frames from data link layer to electrical based on the physical cable. If you are using copper, it converts into electrical. If you are using fiber, it converts into optical, and if you are using wireless connections, it converts into the radio signals. So that was the brief discussion about OSI model. Here I will show how the data will encapsulate at the sender side, and how it will decapsulate at the receiver end. So when transport layer receives data from the top 3 layers, it will add L4 header. As I told earlier, it will break the large piece of data into the smaller segments. So for each segment, it will add L4 header. In L4 header, we usually have a port numbers, so that when the data is reassembled at the receiver end, it can identified by using those port numbers. So after assigning L4 header to the data, it moves to the network layer. And before that, the data at this level, at this stage, we call this data as a segment. And then moving to the network layer. So here for the data we will add L3 header. So in the L3 header we usually add IP address, source IP address and destination IP address, so that the destination will identify its packet. If it is belongs to it, it will take it. If it's not, it will discard it. At this stage the data will called as a packet. And then moving to the data link layer. Here the data link layer will add L2 header and trailer, where we have MAC source and source and destination MAC addresses. At this stage we call it as a frame. And then it will transfer from through the physical cable, and it will come to the receiver end. And when it comes to the receiver end at the data link layer, it will decapsulate the L2 header and L2 trailer, and it will move to the network layer. And at the network layer, it will decapsulate the L3 header, and it moves to the transport layer, and the transport layer will decapsulate the L4 header, and it will check their ports, and it will reassemble all the segments into the large piece of data, and the data will reach us the receiver end. So that was the information about the OSI model. So how the data is encapsulated at the sender end and how it was decapsulated at the receiver end. So we discussed a lot. In the next video, I will show you how to use the packet tracer. So see you on the next video.